All right, so this video it talks about how we use trigonometry with real-life objects in real-life situations. Before, we've always done trigonometry with kind of these triangles that we've just given to you. So like on a worksheet, it's just a triangle in free space. And I mean, we're going to still use the same mathematics to solve this, but what we're going to look at now is how these triangles are actually used in real-life situations. So with 21 and 22, for example, you'll notice that with buildings or with bridges, there are right triangles that exist in real-life architecture, okay? And so we use right triangles to solve these kind of problems, and so now we're going to get some exposure to how to do that, okay? So number 21, the angle of depression from a top of a 320-foot building to the top of a 200-foot building is 55 degrees. So angle of depression, we talked about that in class, but I'll re-explain it here in a second because I know some of you are like, what? Angle of depression? I don't know what that means. So how far apart are the buildings? Okay, and notice how it gives you X there in the word problem, so we'll talk about that. All right, first thing let's talk about is the angle of depression, okay? So usually when we think of depression, I don't want you to get all like emo and say like, man, I'm depressed, I'm emotional. No, that's not what we're talking about here. This is math, not psychology class. So what we're talking about here is an idea that when you look at an angle of depression, it's something that starts up top and then comes down. Okay? So something that starts up top and then comes down is what we're focused on. So in this problem, from the top building to the bottom building, it is 55 degrees. So you'll notice that from this point of view down to this point of view, it is 55 degrees. Okay, so that's how they're getting that there. All right, and they want to know the distance between the buildings. Okay, so I'm going to put that distance up here. So this is X. Okay, we know that angle's 55. Okay, and then if I'm really smart, okay, I know that they told us the height of the building, so they know this one's 320, and they know the smaller building's 200. So what's the difference between the height of the buildings? Okay, well that would be 320 minus 200, which would give me 120. So, by just some simple calculations here, even though they didn't specifically tell us, I know that the distance between the height difference between the two buildings is 120 feet. Okay, and so here's what they basically want to know. So if I were to redraw that triangle that we're up there, so we know that's 55 degrees, okay, we know that's going to be X, we know that this is 120, okay, the one thing they don't show us is that, well, this is going to be a right angle, okay, because, I mean, if you're looking at the diagram, let me go ahead and erase my sloppy work here. If I look at the diagram, right, if I go from here to here straight down, that's going to make a right angle right here, okay. So that is where our right angle exists. So if this is a right triangle, that opens up a whole world of possibilities to me. That means I can do some basic trigonometry. Okay? So if this is 55, and that means this is 35, okay? If we need to find out what x is, we simply just do our calculations. So let's say I do trigonometry from here. I know that this is the opposite. This is the adjacent. Okay? And this is the hypotenuse. All right, for this particular triangle, I know nothing about the hypotenuse. So opposite and adjacent, that's used by tangent. So tangent of 55 degrees equals 120 over x. Okay, from here, I would try to make tangent into a decimal. So let me go ahead and do that with my fancy calculator here. So 55 degrees, the tangent of that is 1.4281 equals 120 over x. Okay, we would cross multiply at this point. So 120 equals 1.4281x. And then you would divide by 1.4281 on both sides. And that's going to give you an answer of x equals 120 divided by 1.4281. 81. And that's going to give me 84 point, we'll just say 0.0 there for the nearest tenth. So that is the distance between two buildings. And the way we were able to calculate that is because we knew the angle of depression, meaning from the top down, starting from the top and looking down. That's the angle of depression. And then we had to make a right triangle. And we moved x from that bottom part to the top part here. And we knew the distance gap between the two heights of the buildings was 120. And we were able to solve that right triangle. So that's number 21. I'll do another video about number 22.